Hey guys, I'm here to show you how to work through the Unit 9 using a pendulum to measure the acceleration due to the force of gravity lab. And so one of the first things that you want to do is either the link that is on the Google Classroom assignment or this link right here. Click on it to make sure that you have the Pendulum Lab simulation from the FET Colorado website pulled up, and go ahead and click on the intro. So we'll come back to this, but this is your main setup that you're going to want to use. So I'm not going to read through everything. You guys can do that. I'm just going to highlight some key features. So the first up is the pre-lab discussion. There are 6 questions, but if you will notice, 4, 5, and 6 have all been crossed through. Each of these I feel have already been asked later in the lab, so I felt it was very unnecessary and honestly a little difficult to answer them as pre-lab questions, so you do not have to do questions 4, 5, or 6 for the pre-lab. However, questions 1, 2, and 3 you do need to answer. Question number 3 is going to be a little bit easier to answer after we talk about Part B. So looking at the lab itself, we're not using these materials. Instead, we are using the Pendulum Lab. And so that goes with the safety. Since we're using a virtual lab, there's not really much that we can do. Under the procedure, it is split into parts A and part B. Taking a look at part A, we're kind of skipping over all of step 1 and the first part of step 2 because that is setting up the actual physical lab. So if we were doing this lab in the classroom in a normal setting, then we would be looking at those, but since we're not, everything is again already set up. We have our protractor here at the top, we have our meter stick off to the side, and we can adjust the length of everything. So this is actually what it is when you guys first pull up. My apologies. And so if you want to, there is a stopwatch function available. However, it is a little difficult to use, as we shall see. Make sure that the friction is set to none and that your gravity is set for that of Earth. You are more than welcome to play around with this as much as you want, but do that on your own time. For this lab, specifically, we are looking at Earth's gravity, and there is very minimal friction for this lab, enough to where it be considered negligible. If you look at part 2, it's talking about on the pendulum, the length needs to be 1 meter, so 1 meter below the metal rod, and then you also have a 100-gram mass. Well, that 100-gram mass, well, ours is measured in kilograms, so drops it all the way down to 0.1 kilograms, and then we have a 1 meter length of rope. So this is what your setup should look like with 1 meter and 0.01 kilograms as your mass. And that takes you through steps 1 and step 2. Step number 3, this whole paragraph right here, I broke down and restated right here. It's the exact same thing. I'm a bullet point person, as you guys know, and so everything that it says in this paragraph, I have just reworded right here. So to simplify, here's your protractor, and if it is hanging down, straight down, then that is at 0 degrees. If I move it to the left, you notice that I now have I have the negative degree function. And if I move it to the right, then I have a positive degree function. And so that takes care of the first one. And so I ask you to practice moving the pendulum bob so that it's at a 10-degree angle. And so when you move it, the tiny first dash is 5, so our first larger dash is 10. And when you release it, that is when it starts to swing back and forth, and because it's frictionless, it will go on forever and ever and ever and ever and so on and so forth. And so just practice getting used to bringing it to that 10 mark so you can kind of get a feel for where things are at. That's part B. Part C, there is a stopwatch function available right here, so you click play, it starts recording things, and it is possible to use it for the experiment. It's a little difficult to use it, and I'll explain here in a minute. So part D is measure the time it takes for a pendulum to make 20 complete back and forth swings at a 10-degree angle, and record this time in data table 1. So up until this point, for your pre-lab questions, you're going to answer them right here on these lines. You can delete the lines and put in your own answer. Please make sure that all of your answers are in red. If they're in black or if they are in blue, it's going to be really hard hard to decipher those from what the original lab was and what I put in. So if you type your answers in red, it will be a lot easier and a lot quicker for me to pick it out. So up until now, you're putting your answers here, but once you get to the procedure part of the lab, you are going to put all of your data points into the data table, which if you scroll down is right here under the observations section where you have data table 1. So we're looking at our starting position. So our first one is 10 degrees, and we want to know how long it takes for 20 swings. So how many seconds? So there's a couple of different ways that you can do this. If you don't want to use the stopwatch function on here, you can pull it back to the 10 degrees. And if you have a stopwatch on, say, your phone or something, that would be really useful because then you can just click as soon as you release. And there's 1, 2, 3. So what we are calculating is how many times it swings back and forth. So I'm going to start right here at the 10 mark. And so it's going back and forth. That's 1. Back and forth. That's 2, 3, 4, so on and so forth. I don't have enough time for it to count back to 20. So it is possible to do that. Another option that you can do is you can start the timer on here and then move the pendulum and release it at a specific time that you can subtract. So say, for example, I am going to start the stopwatch, and when it hits the 10-second mark, that is when I'm going to release it from the 10-degree angle. So as an example there, I have it started. Here's my 10-degree angle. I could start it at 5 seconds if I felt more comfortable, but I wanted to wait for the 10. So 9, 10, I release. And so then I would count back and forth 20 times that this swings and however long that takes. So we're going to stop and pretend that it takes that long. So now I have 19.91. Well, because I started at the 10-second mark, I need to subtract 10 seconds from this. So if you want to use the stopwatch function on here, you are more than welcome to. Just make sure you subtract the initial time that you release it. That is a perfectly viable option. And so then however long that took, that is what you are going to put for your 20 swings. And then that takes you through everything on part 3. Part 4, you're going to do the exact same thing that you did for step 3. Only this time, rather than releasing it at 10 degrees, you are now going to release it at 20 degrees, let it swing back and forth 20 times, and record your seconds. And then you're going to do it again for 30 degrees, and then, of course, recording how long it takes for that many seconds as well. And that takes you through part 4 and recording your 20 and 30 degree angle swing times there. So then we are looking at part number 5, where it is to calculate the period of the pendulum by dividing the time it takes the pendulum to make 20 complete swings. So basically what you're doing is, all right, so we have our 10-degree angle. We'll say it took 20 seconds. Okay, well, if it took 20 seconds, I need to divide 20 seconds by 20 swings, or 20 periods. So 20 divided by 20 equals 1, so it takes 1 second per period. That is what you're basically doing. So however long it took, and you're dividing it by 20. And that is that for part 5. And then you're going to make a graph of everything. And I am going to upload a separate, or actually I have uploaded the separate video of how to modify graphs on here. And I have 3 different graphs at the bottom of everything. So if we scroll all the way down here, hey, so here's graph number 1, graph number 2, and graph number 3. And you are more than welcome to edit these however much you want. Image options, there it is. And so again, I have another video of how to edit the graphs, and so you can plot your data points and draw a line connecting those data points, but of course please make sure that you label your axes as well for that. And that's everything for part 6, and I'm going to have another video here in a moment that will talk about part B and the analysis and conclusion sections. So thank you guys.